A mysterious underground tunnel system lies below an ancient city in southwest England.
It's got quite a lot of medieval graffiti on it.
What was its purpose, and how has it evolved over time? Thousands of miles away in Vermont, a subterranean city that's rock solid. How has this mine stayed at the forefront of its industry for over a century?
We just pulled out of there 34 tons of select Olympian white.
And buried under the tiny country of Moldova in Eastern Europe is a massive underground city stocked with barrels of liquid gold.
They are considered to be the most expensive wines from the whole world.
Beneath our feet lie extraordinary subterranean spaces.
We're miles away from civilization down here.
Caves, mines, and networks of tunnels.
The jewel in the crown for underground technology.
Some designed and built by humans. Others formed by nature over millions of years. How were they created and adapted? By whom and why?
If the enemy takes one section, he's not able to stand down there and shoot into the other section.
Throughout history, life underground has captured our imagination.
It creates very frightening but also very beautiful experience.
Now we're taking you further and deeper.
There's all kinds of wild theories about what could be below.
To unearth the mysteries, the secrets, and the wonders of these underground worlds. Beneath the modern-day city of Exeter in southwest England lies a hidden world of medieval engineering.
There's no escaping it. It's an impressive affair.
Spanning nearly 500 meters across the city, this network of ancient underground passages provided locals with access to a vital natural resource. How did this ambitious infrastructure project help save lives during one of the deadliest epidemics in history?
A terrifying disease was sweeping across Europe.
And how is the system evolving for the future?
There's modern bricks and concrete adjacent to a passage which dates from the 14th century.
Buried 6 meters under the bustling streets of Exeter are the remains of a network of tunnels with a fascinating story to tell.
You'd never believe that in this unpromising setting there actually is a very fascinating medieval world tucked away out of view.
Accessed through an unassuming entrance, this maze of passages stretches right across the city.
Just as we come through here into the first bit of the passages is a really interesting stretch.
Archaeologist John Allen is an expert on the city's ancient subterranean tunnel system.
This is a little bridge underneath a medieval street. The street itself is all gone, of course, but you can see here that they've made special effort to build a vault, which is made with these blocks. They're very nicely finished with a fine chisel.
Before this impressive system was built, Exeter's water supply came from natural springs at the surface, allowing early inhabitants to establish a settlement. But by the Middle Ages, supplying Exeter with fresh water became a huge logistical challenge. Professor Mark Stoyle is an expert on the region's rich history and evolving infrastructure.
During the 1100s, the cathedral first decided to build a gravity flow aqueduct. And it's partly for prestige, but it's also, of course, because these great monastic houses and cathedrals needed a lot of water for ritual purposes. They also needed them to supply the senior clergy with piped water of their own, which was great luxury.
By the 12th century, as the city's population increased, so had the need for clean water. The church enlisted engineers to search for a new source of water in the nearby city of St. Sidwell.
The earliest pipe system did indeed just line a deep trench under the ground. Water was brought into the city from springs which lay outside the city walls, underneath the walls, where it would be distributed from public fountains.
The springs brought water into the city via lead pipes buried under the ground. But pumping the water from St. Sidwell's uphill to the cathedral was a challenge. So the medieval engineers installed a siphon system, similar to those used by the ancient Greeks, Egyptians, and Romans. Siphons allow water to be drawn upwards without the use of pumps. A combination of gravity and atmospheric pressure forced the water through the lead pipes as they climbed uphill. By 1346, construction began on Exeter's first underground section, known as the Cathedral Passage.
This length of passage was built by cut and cover. You'd first dig the trench, and then you'd line the bottom of it with stone and build up walls in the bottom. Then you'd need to build a vault, which you'd do with wooden sentry, and once that had set, you'd then backfill.
These passageways were carefully constructed. First, lead pipes were laid along the floor. Then the space was covered with vaulting stones and filled in. Manholes were also constructed along the route, allowing easy access for the medieval plumbers.
You can see the footholes at the bottom of a square manhole, which rises up, and we're about 5 meters deep here.
Even though the Cathedral Passage delivered clean water to Exeter's clergy, it wasn't nearly enough to supply the rest of the population.
The town councillors were very anxious to secure a water supply of their own, rather than to simply piggyback on the cathedral system.
From the scant supply designated for the public, the wealthy were allowed to have water piped directly into their homes. For everyone else, the water that remained was dispensed through a public fountain known as the Great Conduit, located in the centre of the city.
They also had lots of deep wells, which they called tie pits. Those became increasingly polluted by human effluent and so forth.
By the 15th century, in response to the public outcry, a second underground water system was built, large enough to serve the entire city population.
We're in a structure which is now called the East Gate Chamber, and this is the earliest part of the city passages in Exeter. Behind me here, you can see the foundations of the old Exeter East Gate. If we look up here, just above me, we can see the original medieval door which gave access to that chamber that we think was probably built in about the year 1420. And you can see a set of stone steps leading down into the chamber itself.
Today, local historians and underground enthusiasts like Mark are still uncovering new finds.
It's actually the original medieval housing for the lead pipe of the city aqueduct. And so when the pipe emerged from this little chamber, it did so through this big square stone, which has this beautiful hole in the middle. It's got quite a lot of medieval graffiti on it.
The siphon system was expanded over the next few hundred years.
During the reign of Henry VIII, the system was expanded to Carfax, the great central crossroads of the city, where a splendid ornate fountain was erected from which all of the citizens could come to collect their water.
Despite the political turmoil during this time, the underground tunnels lying below the city survived for centuries, largely intact. However, in the 1600s, during the English Civil War, Exeter's precious water supply was compromised.
The ruling authorities in Exeter decided to declare on the side of Parliament and to turn the city essentially into a fortified stronghold.
Residents of Exeter grew concerned that the opposition forces would sneak into the tunnels and either cut off the critical water supply or gain access into the city.
They feared that it was possible that royalist conspirators might get into these vaults and somehow use them either to blow up the East Gate itself or to force a passage into the city underground.
The lead pipes were removed to be cast into bullets, and the passageways were filled with debris.
The conduit houses, the banks on which the pipes ran, were broken up and destroyed. The trapdoors were broken up and burnt for firewood. By the time the city surrendered in 1646 and the parliamentarian troops marched in, Exeter's systems of public water supply had been effectively destroyed.
After the war ended, the vital water system was repaired and restored. By the 19th century, the underground network saw yet more change when a deadly epidemic wreaked havoc on the city. In the fall of 1831, cholera was spreading like wildfire across Europe, and Exeter's officials began to prepare the city for the disease, if and when it arrived.
A terrifying disease, cholera, was sweeping across Europe. The citizens of Exeter, like people in cities and towns all over England, knew that it was heading towards them.
Once the connection was made between unsanitary water and cholera, the Board of Health acted fast and commissioned local engineer James Goldsworthy to make some updates to the passages.
Goldsworthy went right back to basics. He went back to the well heads from where the water was brought. He sort of re-edified them.
To improve water flow, they changed the position of the pipes.
They dug the floor of the passages much deeper in order to allow the pipes to be laid lower down. You can see here, this is a section where the original floor would probably have been about here at the passage. It's been substantially cut away to make the trench much deeper.
By this time, engineers had learned that lead pipes could cause poisoning, so Goldsworthy replaced them with cast iron ones.
The whole shape of the passages has changed to more like a coffin shape. This is a result of Goldsworthy's work. The top of the passage is still Tudor work, but the bottom is very much 19th century, and that's why it's got such a different profile to the initial medieval sections.
The passages continued to supply water to the city until 1857, when one of the wells was damaged during the construction of Exeter's railway. By 1901, the passages had been abandoned, but not forgotten. Nearly 700 years after they were originally built, the tunnels were repurposed to serve a new function.
In 1942, Exeter suffered terrible damage following Baedeker raid, a blitz, and a lot of the medieval city was lost in the centre, and the sites were cleared.
Hitler was enraged by the Royal Air Force's bombing of historic German cities. So he decided to launch a series of raids on some of England's most beautiful but strategic towns. Exeter was one of the first to be hit. 2 nights of intensive bombing left the city devastated. Some had taken shelter in the tunnels, but above ground, the city was annihilated and 265 people were killed. Following these fateful nights, much of the city was rebuilt, and by the end of the war, the underground tunnel network was rediscovered. Dave Adcock is part of a team tasked with protecting the tunnels while the city undergoes new construction above.
It was important that we preserve this scheduled ancient monument to make sure no damage happens. The developers had to follow certain rules and regulations in relation to protecting the passages, but you can see there's modern bricks and concrete adjacent to a passage which dates from the 14th century.
Striking a balance between preserving the old city below ground while developing a modern one above is no easy feat.
The area where we are now is actually incredibly fragile, and we're very close to the surface. So it was important throughout the development that no damage happened to here. It was protected. We had vibration monitors, we had a full structural survey, and also just above here we had crash pads. So during the demolition, no damage occurred to the passages.
The constant monitoring of the passages over the years has thrown up some mysterious anomalies.
Generally, the passages are dry, but as you can see here, particularly after rain, water will percolate through the street level down to here. As you can see, it's dripping. But also sometimes there'll be dripping and puddles when there hasn't been any rain. We're not really sure why that is, but we suspect that behind the vaulting and the passages that there may be sort of voids or old basements. We don't really know.
What other hidden mysteries still linger under Exeter? That remains to be seen. An unexpected natural wonder is hiding 2.5 kilometers under Vermont. Carved into the Dorset Mountains is the entrance to a mine shaft that's been in use for over 100 years. How did this area become one of the largest suppliers of the world's most recognizable building material?
He used his political influence to ensure that marble was used on the United States Supreme Court.
How has modern technology played a role in producing this coveted rock form?
Don't forget you got another quarry above here.
And how long can these mountains keep providing a building material that never seems to go out of style? Marble is one of the oldest and most beautiful stones on the market, and it's just as popular today as it was thousands of years ago. 3 of the 7 wonders of the ancient world were made from the stone. The Temple of Artemis at Ephesus, the lighthouse at Alexandria, and the mausoleum at Halicarnassus were all built from the finest marble. This classic rock form remains a symbol of opulence and luxury throughout the world, and this quarry in Vermont has lots of it. While the entrance to the mine has been used for over a century, a lot has changed since 1902. Keith Millard is the quarry manager.
About 140 metric tons of marble is removed each day from this mine. We only save about 70 metric ton of it. The rest of it is thrown over the bank because of quality, cracks, just because of defection in the stone.
The marble vein is located at the base of the mountain, forcing the original miners to dig through the middle of the landmass to extract the precious mineral.
The purpose of the quarry being underground is you can never cost-effectively move the overburden. Overburden here might be 150 feet. Down the bottom of the quarry is almost 700 feet. By the time you move the overburden, it wouldn't be cost-effective to quarry this marble. Quarrying methods up until 1970, everything was drilled and blasted and taken out with cables and derricks. From 1970 on, they're using heavy equipment to remove marble from the earth. Things are cut with chainsaws, diamond segments, diamond blades, makes things more efficient. So the original tunnel is cut through the mountain with what we call a mobile gallery saw. The mobile gallery saw is able to move all around in here. It comes up, puts the first horizontal cut in, the second horizontal, the third horizontal, and then the top. So you can see this blade, it's 2 meters deep, putting a cut down through the mountain. Basically, you got diamond segments, so the blade can come down through the wall.
Due to the hardness of diamonds, this abrasion technique cuts through marble almost effortlessly.
So the diamonds grind that limestone up into small fragments, basically turns it into mud. After that, put water bag cushions in the blocks, we'll blow them up and we'll break the blocks off, and then come in with a loader and pick them out one at a time with the loader.
Marble is difficult to mine.
Got it.
In contrast to mining for metal ore, where pulling out rock fragments is standard practice, marble has to be extracted in the largest possible unbroken blocks for maximum value.
After the original tunnel is made with a gallery saw, You have a nice hole and an open floor. We come back with this Fantini floor saw. This saw has a 6-meter bar on it, which swings down into these cuts and slices these into blocks. After they're cut into blocks, we wrap a wire around them, wire saw the bottom off. Then the block is free from the mountain.
The solid blocks of marble, destined for consumer use, require some heavy lifting.
We're bringing a 50-ton excavator in, and he's gonna reach up and he's gonna tip that layer right over. When you're tipping it over, go easy. All right, it's all right. Easy.
Vermont is often associated with pure white marble, and Danby Quarries is considered the finest in the world. The huge, heavy marble blocks are difficult to move.
These beds run on about a 45-degree angle, so we're taking this and we're following that bed. So we're gonna cut it here, we're gonna put a square on it, we're gonna cut it over here. We're trying to separate these dark colors so we can get all this white right here. Probably 40 inches, and then when we're all said and done, we'll have a nice square block.
Another remarkable characteristic of Vermont marble is its veining. Luca is the general manager of the quarry and a geologist by trade.
This makes unique this quarry. In the same marble deposit, we have 10 different layers. This variation in the veining is a consequence of several metamorphic phases.
The rock begins as limestone, then, through the metamorphic process, changes into hardened, more luxurious marble over millions of years.
This veining, from south going to north, we have Maryland behind us and Quebec in that direction.
The rock here is part of an ancient continental shelf that extended up the eastern side of the North American continent.
The Shelburne Formation, it's a very well-known marble formation, marble deposit. It's dated from the beginning of the sedimentary process, the 600 million years ago, when ancient living organism in a marine environment died, making it a huge deposit of calcium carbonate limestone.
Vermont marble has played a key role in building America since the early 19th century, and it would be difficult to find a significant building or monument that doesn't have Vermont marble somewhere in it. Peter Pravulovich is the director of Danby Quarry and has studied its history extensively.
Our quarry spans 3/4 of a mile north to south and roughly 600 feet east to west. So we're now in one of the older sections of the mine. The quarry was originally opened in 1850s. In 1880s is when Vermont Marble Company took over and most of the production started.
Over time, demand grew for the versatile and attractive building material. By the early 19th century, the residents of Vermont were convinced that marble was the key to growing their economy.
Companies started popping up along the marble belt and producing different types of marble and having their own shops. The shops included cutting the blocks, polishing the pieces, and shipping them to other locations.
But mining back then wasn't the same as it is today. Before modern equipment and safety gear, these caverns were hot, uncomfortable, and dangerous. In fact, the industry didn't truly take off until the innovations of one man changed Danby from a boutique quarry operation into a global marble powerhouse.
In 1880, many of the entrepreneurs sort of joined forces and created one large company. It was known as Vermont Marble Company. It was headed by Redfield Proctor. They became one of the largest corporations in the United States and one of the world's largest marble companies.
Redfield Proctor, used his business success to propel his political career, serving as governor of Vermont and even Secretary of War under President Benjamin Harrison.
He used his political influence to ensure that marble from quarries in Vermont was used on many of the federal buildings around the country. Some of the more notable structures that were constructed using Vermont marble are United States Supreme Court, New York Public Library, the Arlington National Cemetery, as well as many more.
Making sure they can continue quarrying this timeless building material requires miners to maintain the safety of this space.
So the room and pillar method has been around since the early 1900s. Most of the pillars are about every 40 feet apart. You're creating structure to support the ceiling. And don't forget, you got another quarry above here. So a lot of these pillars are stacked one on top of each other from one quarry to the other quarry.
The positioning of the pillars is vital to the structural integrity of the mine, and the site designers are meticulous in their excavation planning.
3D mapping helps us understand where to chase the vein through the mountain. They are able to tell us within 1 inch of where we are structurally, from lining piers up from one quarry to the other, to where do we want to drill my phone line? Where do I want to put my emergency things in? So it helps us in many things because it's so precise and lets us know to the inch exactly where we are.
This environment can be unforgiving if you make one full step.
We just pulled out of there 34 tons of select Olympian white. No cracks in it, beautiful block. That'll be flipped up and then cut across the vein, and then it'll be made into slabs, sent out for kitchen countertops. You could go for Arlington headstones, depends on what it is, whether it's got any cracks or feathers in it.
But it's not just the quantity and quality of rock buried inside this mountain that makes this marble unique. It's what's operating hundreds of feet below it. Since it began operating in 1903, the marble mined in this Vermont quarry has been considered some of the best in the world. The mine encompasses various layers, each with different characteristics, allowing operators to extract more than 10 different types of marble. But even though Danby marble has been used in the construction of famous buildings all over the world, what few people know is that hundreds of feet under the ground, inside the same quarry walls where marble is extracted, there is a fully operational production facility.
In the early 2000s, we started creating a factory inside of the voids that have been quarried in the past to start producing our own material into slabs and cut to size material.
So this is a block that was just removed from the Brook Quarry. We're bringing it up, weighs about 65,000 pounds. So what he's doing is he's trying to get that block very nice and square on there so we get every slab that we can out of this block. Right now they're mixing mortar. They put it underneath the block so when the gang saw blades go down through, the slabs can't shift or move side to side in the gang saw cart, and it'll hold them upright after they're all cut into 2 cm slabs. All right, guys, go ahead, put the cables around it, pick it up, bring it down, put it on the car.
To cut the marble into blocks, the quarry workers use a giant cutting machine that operates just like a bread slicer.
So basically these blades, back and forth, slice this block into 3 cm slabs. These are diamond segments that are soldered onto these blades that actually cut through this marble. The purpose of the water keeps the gang saw blades, the diamond gang saw blades, when they're going through the marble, keeps them cool. Otherwise they'll heat up and break.
Due to its clean appearance, this marble is a popular countertop option, and these thin slabs will be shipped around the world for use in luxury kitchens.
We just separated about 60,000 pounds of slabs right there. Putting wedges in there to make sure they don't tip or slam back together. So we brought this block in, it weighed about 45,000 pounds, put it in the gang saw, cut it into 39 3 cm slabs, made beautiful Eureka slabs. They weigh about 1,100 pounds apiece.
All of the finishing touches are done in this cavern, and the final stage is grinding down the rough mined surfaces and polishing the slabs to a high shine.
They'll be brought from here over and put on this auto loader, set on and go through the polish line, and they'll be ready for sale.
Advances in technology and efficiency at Danby Quarry have allowed miners to continue producing this coveted mineral for over a century. And the world's love of marble hasn't slowed. It is still the stone of choice for any opulent building. For these reasons, the quarry is likely to survive into the next decades, or possibly centuries. Blanketed by the rolling hillsides of Moldova lies a world hidden from sight. 120 kilometers of winding tunnels and mazes, more than 60 meters underground, contain the secret to the country's success.
For Moldovan people, wine is a part of our life.
Rich in history and geology, this massive subterranean city is unlike any place in the world. But it would take decades before this region could distance itself from the Eastern Bloc and come into their own.
It was a very difficult period for our winemakers.
How does the unique geology of these caverns contribute to the thriving wine production?
It doesn't matter what season is outside. Inside the cellar is always 12, 14 degrees.
What caused the nation's most successful industry to come to the brink of disaster?
That's why in that period, a large part of our vineyards was destroyed.
And how did Moldova's most flourishing product make an epic comeback? Tucked away between Romania and Ukraine is the nation of Moldova. And more than 25% of the country's population is involved in wine production. Rich soils and vine-covered hills can be found at every turn, and its sunny slopes contain the ideal conditions for growing grapes.
Our country is a small one, but we have the same climate like French region, which is well known by winemakers. That's why we are blessed to make good wines, very special wine, and the same quality, why not better than French.
But before this region was known internationally for its wine, it extracted another precious commodity from the ground, one that helped build the Moldova we see today. The land in this area of Moldova was formed 12 million years ago, during the Miocene period, when it was under the ocean. A reef rich with organisms thrived, leaving behind deep reserves of limestone.
We are inside of Krikova mine. This mine produces limestones that used in construction in Chisinau city and nearest area.
Igor Nicoara is an expert on the region's geology and its mining history.
On this wall we see results of industrial extraction of limestones. Production in a mine of limestone started in 15th century. Some people come here, obtain stone and use for construction in local area, also in Chisinau.
The vast 120-kilometer network of Krikova caves was originally created by centuries of mining.
Here we can see some boreholes that help to detailed geological prospection of rocks. We see different kinds of limestones, but for industrial production it's very important to have same quality of rock.
This method of horizontal excavation through galleries and rooms was invented in Moldova.
We want to connect two different galleries it's important to know if they have quality of rocks.
This method was used because the best limestone vein was at a certain depth and was only 20 meters from top to bottom.
If we go a little deeper, quality of limestones change. If we go a little higher, also changed. For limestones, we must have especially density. It must be enough resistant to prepare with soil. If it's a little higher density, we destroy soil.
Thanks to the tunnels left behind by centuries of limestone mining, Moldova's wine industry was able to grow exponentially. Once the major producer of wine for the Russians, the country was running out of room to store its precious export. Creative winemakers ventured underground into some abandoned limestone mine tunnels and found the perfect environment in which to store their libations.
It doesn't matter what season is outside. Inside the cellar is always 12-14 degrees.
Temperatures in Krikova's subterranean network do not fluctuate, and 12 to 14 degrees is the temperature for wine aging and storing. Natalia Solari is an expert on the nation's wine industry.
The humidity here in the cellar, it is sometimes about 97 or 98%. That means that here we have wonderful conditions for storing the wine.
The science of wine aging all comes down to where it's stored. Storing wines in humid conditions helps prevent the cork from drying out, which could allow oxygen to enter the bottle and oxidize the wine. At the winery, over 7 million gallons of wine are stored in oak barrels.
We have oak in our country, but the quality of the oak is not so high. We import the oak barrels from different countries, from France, Spain, Italy, and some of them from the United States of America.
The chemical processes that occur in the oak barrels give the wine a fuller body and more complex taste. But the most remarkable impact the oak barrels made was during World War II, and it had nothing to do with wine at all. Jewish citizens, fearing for their lives, fled to the tunnels and hid from the Nazis in the oak barrels. Eventually, the tunnels would come to serve a livelier purpose, when, in 1952, Stalin ordered for 5 tasting halls to be added to Krikova's subterranean network. During this time, the site became a key destination for all official delegations to the USSR. They also received a visit from the first man in space, Yuri Gagarin.
This hall was called Gagarin's Hall in his honor. Gagarin got lost in our cellar, stayed here for 1 day, and wrote us a letter in which he said that for him it was easy to go in space than to go out from our cellar, because he really got lost here.
The tunnels are home to some of the world's finest wines. Storing these vintage wines requires specialist methods. One vintage wine of note is a dessert wine called Easter Jerusalem, produced in 1902.
They produced around 400 bottles of wine. Some of those bottles of wines, they were opened then, drunk, some of them just disappeared. There are only 1 bottle of wine in the whole world which is keeping here in our national collection.
Shockingly, the most valuable collection currently stored here belonged to Hermann Goering, Commander-in-Chief of Hitler's Air Force.
After the Second World War, all the bottles from Goering collection, they were confiscated by Russian army. The bottles were shipped in Russia, where Russian soldier had drunk, remaining around 4,000 bottles of wine. They are considered to be the most expensive wines from the whole world.
By the mid-1980s, Moldova's wine industry surprisingly fell victim to a country in crisis, when an unexpected change in policy turned the tide for these skilled winemakers. mid-1980s, Soviet President Mikhail Gorbachev attempted to curb alcohol abuse by launching a partial prohibition campaign, and it took a toll on the Moldovan winemakers. 1/3 of vineyards were forced to close.
Our Moldovan wine production was affected by anti-alcoholic order from 1985. That's why in that period, large part of our vineyards was destroyed.
In 1991, Moldova gained her independence. And over the next 2 decades, wine production began to grow again, with Russia still its major consumer. But in 2006, Russia issued an embargo that sent the smaller country into yet another crisis.
Our industry was put down about 75–80%. It was a very difficult period for our winemakers.
With the embargo, the Moldovan wine industry had to rethink its game plan. Losing Russia meant they had to turn to other markets.
It was a lesson to produce better wines and to occupy our wines in other places, in other countries.
Although the embargo was lifted, today Moldova has future-proofed itself and exports to 50 countries across Asia, Western Europe, and the US.
Now we can say that Russia it's only about 10% of our export in our country, and a biggest part, the 19%, it's in other countries of the world. Moldova is the 11th largest production of wine in Europe, about 2 billion hectoliters of wine.
Some of the wine produced here is world-leading in its class.
Here we are at the sparkling wine factory, and this is the deepest point in our cellar because here we are around 100 meters down.
The sparkling wine is made using the French champenoise method.
The first alcoholic fermentation took place in big stainless tanks.
The alcohol is then bottled, and a liquid solution containing yeast and sugar called liqueur de tirage is added.
The second alcoholic fermentation, and the most important stage, because we'll transform a still wine into an effervescent one, into sparkling.
During fermentation, sugar consumes all the yeast, producing alcohol and carbon dioxide. Trapped inside the bottle, it forms bubbles. The bottles are then placed upside down to ensure all the sediment gradually accumulates in the neck of the bottle.
Every 2 days, all the bottles that we have here, they are turned by hand under an angle of 45 degrees.
A team of workers rotates as many as 35,000 bottles of the sparkling wine every day.
In 8–10 weeks, the bottle will change the angle, and the sediments from inside that you saw, they will be collected here on the crown caps.
The sediment is then frozen, cooled to minus 25 degrees Celsius, and removed in the disgorgement process.
The crown caps, they will be just popped out under the high pressure, which exists already in the bottle of sparkling wine.
Now Moldova's wine industry is thriving, and the Craiova cellars continue to grow. At the far end of the caverns, miners are still extracting limestone, which means more and more space will become available for winemaking in the future.